One of the things, we have a booth upstairs for anyone that wants to actually feel and touch and get more in contact with the different stuff that we have. I will give just a brief description. I will try to cut out everything that is corporate from the Yanzi presentation and talk more about why we're doing things and a little bit about what technology we're presenting and what fun stuff that you can use, some of the stuff that we have. The background is that Yanzi is a company that's about 6 years old. From the start, it started with Internet of Things products, and we sell mainly into construction business in the Nordics. One thing that came up very, very early was how can someone that have no understanding of Internet install Internet of Things, really, be able to install things at the construction site like a camera or temperature sensors or motion detectors or other things without even picking up a computer. So very early, we had one of the requirements from our customer was that how can we make this so dead simple to install so anyone can do it in 5 minutes? And that was the background for us to develop what we call the wireless product line that we are showing up upstairs. It's the latest generation is full wireless. It's encrypted all the way. It's a single touch for provisioning the systems and so on. And there's a bunch of different sensors. And this presentation, I will just talk a little bit about application that we have designed to use for this solution, and also a little bit about what the developer's kit is, what you can do with the developer's kit. Because we decided very early that there are people that don't want to have the full solution all the way to the moon, but rather want to have some of the stuff and play with and try to see what cool can we do with this? How can we hook this up to something that we want to use ourselves? Okay, so short story. Internet of Things for many people is something that started many, many years ago, and they wanted to know when a frost alarm in their summer house or something like that happened. And it was usually, the first generation was SMS. There was a generation before that, but people start feeling that they are getting in touch with their things and so on in a simple way. The new thing was when the smartphone came, so they could see this in real time in their phone in a smarter message than an SMS. We believe, and as you can see, this screen is not the best. It cuts the presentation, the width of the presentation, but really where we want to go is to provide this integrated solution where you can say, like a security, an automated security system that can be slicker and smarter than what we see today. Such things like when the last person is leaving your home, you will get something pop up in your app and ask you, do you want me to turn on the alarm because you seem to be the last one leaving? That is a typical application for next generation of alarm system. There is even more advanced features that can be done, but I just want to give some of the easy things that we can do with those systems and that people and customers are asking for today. We call this automated security, and there are a bunch of things like motion detectors and door sensors that every security system has today. We believe that there is new things coming out, like we have accelerometer in our products, which means that you can glue things onto like something that is fixed, and whenever it moves, you can actually get the security notification. There's a bunch of new things coming that you want to integrate in a single system. To do this, what Yanzi provides is basically an end-to-end solution. Many different things are included in this. We provide phone applications that runs on iOS or on Android. We provide cloud services like everybody else. There is not a single person I meet every day that doesn't provide a new cloud interface or a cloud solution. We also build actually gateways, both the hardware and software for gateways. This is typically a Linux and Java-based software solution that we integrate heavily with the cloud services. So one thing that we do is that the cloud itself is basically shipping Java objects back and forth between the gateway and the cloud. So the cloud and the gateway, you can see it as one unit that is very tightly integrated. But the last part, which is probably the most interesting here, is that we also build actually hardware sensors and we build hardware software. A lot of the software that we talk about in the sensor here have been developed together with Swedish Institute of Computer Science, and Joachim that presented me here is actually one of the people that I work quite a bit with. there's basically, the models that we are using today are basically one of those two that we see here. Either the small things, and when I say small things, think something like a 16 kilobyte RAM. We have those things that connect up all the way into the cloud with an IPv6 stack. And the cloud, this is kind of the thin client that goes that way. We also have an aggregated point where we have a gateway that contains a lot of state. The reason that the model to the left is a very low cost and low entry point kind of model, which everybody is interested in using. The model to the right, it provides you with other things, like a security system. When internet is down, you still want to be able to disable your security system. That's why the system to the right. The system to the right is much more less affected by internet going down to a specific location. So our system actually supports both those models depending on what the customer wants. Moving on here, we decided to build a set of products here that you can, so to say, put together in a bigger, basically a bigger system that you can use for many things. The things that is listed here are, for example, that's a smoke detector. Up on one side, we have a temperature and humidity sensors. We have cameras. We have LED lamps. That means that we actually go to a LED lamp manufacturer. We take our small chip, put it into the LED lamp itself, so you just screw it up and you have basically made yourself something that you can control remotely. Motion detectors, and we also have a smart plug, like everybody else. There's nothing special with those things. All of those things are really standard, doing what you're expecting. The magic comes when you actually hook them up into a bigger system. What our Internet of Things developers kit is really is that we said, okay, not only do we do this, but we actually provide a standard way for people to play with those things. You can buy these things, you can upgrade them, over-the-air upgrade into each and everything, and you can get source code to play with it. Because there's a lot of people that want to hook up 500 of this or 300 of this and do things. And we did this for the university, and we also did it for some other people that want to do it. And we decided eventually, together with Intel Semiconductor, I think their name is, the big Intel anyhow, to actually put out those developers kit in order to hook them up to other things and make people play with more devices. All the stuff that we have are basically built in order to be self-install. Of course, if someone upgrades their software, there is nothing that guarantees self-install. It depends how well you code. But with our software, they are self-installed completely. With a single click, you can install them. We have gateways that we have with a bunch of stuff in them, 3G and 4G modems and many other things. For example, they have battery operation as well in order to survive even when battery is down. All devices are IP-based. The low-power devices are all IPv6. So they talk IPv6 all the way out to the sensor. And the battery-operated devices are targeting a 10 years battery lifespan. So if you look at the motion detector there, or for example, the temperature humidity sensor up to the left, it's about 2/3 of the whole package is just battery. That's because we want to have extreme long battery time. Because if we talk to some people that have 500 temperature sensors spread into their shop, basically. And those people, if they have a 1 year battery lifetime, they are changing batteries every day on those devices. So what we said was that let's actually take this to the next level. In order to have 500 devices, you don't want to have a short battery lifetime. And our target is 10 years, because that is something that we today have requirements to do on smoke detectors. So it's it's far enough, so no one really cares anymore. The last part here is the remote firmware upgrade for all devices over the air. That means that there is no plugs or anything on the devices in order to hook up and JTAG or do anything like that. You can always program everything over there. You basically have a Java program that ships over the firmware image into the device itself. When we install this, we basically today do a 6-step procedure. This is when we do the full solution. The first part is that you have an app that we use for all installation. And then after that, you have create an account like on Google or anything like that. You put out all the devices and you register the server with the cloud service, basically. That's everybody do this. That's another thing. What we do then is we have a protocol that scans for all of those devices, and you basically connect them in or using your phone. By clicking and basically connect, you get a list of all devices that are available in the room, and after when you do connect, it will actually program them, set up all the encryption pairs and all of that, and then they will be locked into that system. The last part is that you can use the phone for actually doing this. There is an API available in the phone as well, that basically a Java-based API that can be used primarily into the Android to build more of a user experience on that. But so far we haven't launched that outside for public to use because it's not really ready yet. What we're doing is for the developers kit is that we are providing this everything IP all the way to the sensor. The sensors are like that. They either, most of them have 82.15.4 radio, which is a 2.4 gigahertz radio, or some of them can even have Wi-Fi or Ethernet. And then we have gateways that have these different kind of interfaces. With the developers kit, there is no reason to go and get our gateway. If you want to use a Raspberry Pi or anything else, you will be provided with a USB dongle to plug into any PC you feel like, and then you can play with our devices. This is what it looks like. Simple. You get the LED lamp with built-in radio. You get a smart plug that have an energy meter, switch, and actually a temperature sensor. We also get two bare boards that you can do what we call, you can hook up your own sensor basically. It provides a bunch of inputs that you can drop out wherever you want. All of this is provided in a way that you can package. And the software is an open source package that can be downloaded from Swedish Institute of Computer Science. Our stuff basically hooks into their stuff. And the USB thing there is basically a serial port to radio converter, that's it, and then you're up and going. The reason that we use 82.15, none of these two devices that are included here are using batteries. It's not because it cannot do it, it's because that most people are very, when the system goes away and sleeps, it makes it very, very hard to program. If someone wants to add the sleeping facility to it, you can do it yourself in it, but to get up and running fast, use powered because it takes some time before you realize if it's sleeping or not. What basically happens is that you install a native border router that sits into your PC, which is basically an IPv6 router in software that basically connects out into the wireless system. Relatively simple. The hook up your own sensors, I got some questions about that before. It's a very small, it's big as a stamp basically. And some people say you can glue it on anything and you can get your own sensor, your Internet of Things world up and running. Here are some of the stuff, the hardware features on the right. As I said, 16 kilobytes of RAM, which is tons. If you're at my age, we are moving around like in much smaller before. They all have temperature sensors. And some of the numbers here are that we can be as low as 400 nanoamps of power consumption. That's what gives you the ability for 10 years of battery time. Of course, if you're running something, it will start consuming more, but it's a fairly standard ARM-based microcontroller that can be used for many things. On the left side is when you use our standard software, this is what's included basically. The first part is that it's an IPv6 solution. Discover and so on is using UPnP, among other things. The security part is not included, not because it's secret or anything, it's just because it's so hard to get someone that wants to do it the first time and they cannot figure out how to get ECC encryption software working. It takes ages. It supports IPv6 mesh, so you can use multiple nodes and they will actually go route between other nodes, so you can extend your network. There are two images that are checksum verified in the flash, which means that if you, by any reason, screw up one of the images, it won't boot, and you will use the other image. So it's relatively hard to actually brick the system, so you can never do anything. The bare boards, you can actually hook up a JTAG to write over the image, but not for the one that are glued together. Yes. That is what we do, and we sell this as basically a kit that is ready for someone that wants to develop, or we sell it as product where everything works together and connect into our cloud. And all of this is shown up on, 2 stairs up in the booth that we have up there, if anyone is interested. And that was all for me. Any questions?
I can hand the mic to anyone that's... You can try speaking louder.
Just a question. Do you have any plans for integrating the Arduino ecosystem?
We are, yes and no. We are basically plain Java shop. All our 80% of our company is Java development. And that means that Java development and Arduino sits together a little bit. When we work with Intel, one of the first, when we sell out some of the kits that we have, we sell it together with the Galileo kit, which is actually an Arduino x86 sitting in an Arduino board that we're working with it. But we basically plug in our system underneath the Arduino system and hook up straight into the Linux system sitting underneath Arduino. But we haven't really developed anything on top of Arduino or that provides an Arduino service.
I mean, for the sensors, they could have been just Arduino's sensor.
The sensors, today the sensors are primitive IP devices. You open a socket to them, an IPv6 socket actually, but you open a socket, they don't support TCP normally because it takes too much memory, but they support UDP. So you open a socket and you read and write to a port, and they got a web server running that you can get things from them, and you can do other things with them if you want. You can also control the different functions in a pre-packaged part of the system. There's nothing that limits us from hooking it up into Arduino in other ways through software, but we haven't done it.
How much does it cost?
I think it was €129 is the price that they were set. We don't have them, so you cannot take them with you, which is, of course, the reason is that the LED lamp actually came, the LED lamp manufacturing came behind the Chinese New Year that happens right now. We were supposed to get all of it before the Chinese New Year, so we have all of the things, but the lamps are coming in about 2 weeks. Okay?
Okay, I think we need to stop. So